What is up, everyone? Today we are going to re-look at this Power Stroke with a Yamaha engine on it. It's 190cc, and if you watched the other video, we determined that the compression release was not working very well. I then quoted the amount that it was going to cost for it to be repaired, and the owner said no. Makes sense. I only looked at it briefly. I looked at the cam and I figured it was the cam. I decided before I was going to recycle this, take the pump off and everything else, to take another quick look at it because it is a good machine. I have another one, in fact, right there, which is a personal machine I use around the house. And I use that to kind of guide me to see if what was missing, and I found nothing missing. So that led me to believe maybe I just messed up. Maybe there's something wrong. Maybe the rocker arms are bad. I don't know. But what happened might surprise you. Well, hold on there. Over 90% of you, according to YouTube, are not currently subscribed. You're watching this video, but you're currently not subscribed. So I'm going to welcome you to subscribe at the end if this helped you out. I work on a lot of machines, so maybe the machine you're watching is going to be something you own, but who knows? Maybe you own a generator, a pressure washer, a big mower, a chainsaw, a variety of things. The only way to know if I'm going to fix it in the future is by subscribing, and maybe I get to the one that you own and can help you out then too. So I welcome you to subscribe, put a thumbs up if it does help you out. Back to your normal video. In the interest of saving time, this is what went wrong. Not this part exactly, but this fits through the head, through these two holes. This hole on top, completely fine. Not a single problem. Looks great. Perfect. No arguments there. However, the other one is the problem. It's egged out. So every time the compression release or the valves, the cam tries to engage the valve, this rocks a little bit. It's always rocking. I tightened with no gap whatsoever, and it was still rocking. So I looked at the hole, egged out. So I was and not right at the same time. What's the fix of this? It's going to be a new head. However, there's a problem with that. These engines are not that expensive. They're only like $169, $179 on sale, I think. Generally, I think they're like $199 or $219 or something not on sale. That's still an expensive proposition for this particular machine, because those, I did a real brief search and I don't know if they are the right shaft we need and all that nonsense. So I looked at the head, because the valves are good, the cam is good apparently, so is the chain, all of it's good except for that hole is just egged out. Yeah, not the easiest thing to find. So after looking for about 15 to 20 minutes, I did find a couple places that found it, except the cheapest one I was able to find is $111, not including shipping, and that's just not going to fly. You might as well just wait for a new engine and just buy it on sale. So I'm going to kind of go over two potential options here. So let's sit down and think about this, shall we? The first option is going to be we drill it out and we find another one of those that will fit. Shouldn't be that hard. I haven't looked into that quite yet though. I know that's probably a pretty hard metal because it is wearing or it's consistently moving, but that is not hard. That is aluminum. So could be a solution, but in addition to that, we would have to drill the rockers, and if I didn't get it perfectly straight, that could be a problem. I would also have to make some type of top so it wouldn't go through all the way and slip out. That's a problem. Or the other alternative is going to be taking the head off, taking my TIG welder, cleaning the head very well, putting it all back together, and taking the head off, cleaning it, TIG welding that hole shut, or at least mostly shut, and then re-drilling the correct hole size in there. That seems like a whole lot more work, because that's going to require removing the muffler, it's going to require moving the carburetor, it's going to require removing the top here, including the electric start and all that stuff. Well, the button, at least this motor's on the other side. Drilling the top to meet the bottom with a bigger size could be easier, but I'm damaging the top, which is good. I also don't know if I'm able to find the same type of rod. I'm going to go look at my local hardware store in a little bit to see, but the likelihood is kind of minimal. They may or may not have it, but even if I could just get the thickness right, then that would be good, because I could shove a whole lot of rags in here, take the cam out, all that stuff, and drill it and get it going. But my other main concern is how much I'd be drilling it. Am I going to be weakening these mounts and these posts? I don't know. The bottom one's already kind of fat, and that's the one that's having the problem. So that's the hard part. In addition to that, let's see if I can do this well on camera. Sorry. There we go. See the wiggle? The further you press it in, the less, or the more of a wiggle. So the egging is definitely more on the bottom part of the hole. The top part of the hole, well, it does have a little bit of wiggle room, isn't nearly as bad, but they would both have to be done. That's a pretty precise fit. And just when looking at that one, I thought maybe there would be a little wiggle in there. It's pretty much straight, like it's not moving whatsoever, which would make sense. I mean, the compression release is such a minimal amount. I don't know. So that's my predicament, but here's the good part. I own this machine now. I told the owner, like, hey, it's not, I could fix it, but this is the amount of money. And I actually reached out to him saying, hey, guess what? I looked at it a little bit more and I found the true problem. I was a little apprehensive on my diagnosis. I'm glad you didn't go through it, but unfortunately it's even more expensive. So what do you want to do with the machine? And eventually, after a total of $20, I now own this machine. So, having said that, I'm going to do a little bit of research and see, because $20, that carb is worth $20 to me. I mean, just general stuff is worth $20 to me. The pump is definitely worth $20. Maybe one day I just need a pressure washer stand because the one I get is super rotten or just nasty, rust covered, all kinds of stuff. You don't know. So I have good parts here. So 20 is not going to go to waste, but I'm kind of wanting to go check out and see if I can't get a different size rod. So let's figure out how big that is. Got my trusty caliper out, and this is what I came up with. 15/64. So that's an interesting size, to say the least. I've tried that multiple different times and I got the same result. Calipers are, detailed tools, but you also have to be a detailed person to use them correctly. So just to make sure, I did it 3 times. 15/64. So what is that? So if you round up, we're going to be drilling. That's 16/64. That reduces to 8/32, which then reduces to 4/16, which then goes down to a quarter. So a 1/4 inch. I have a 1/4 inch drill bit. My main concern is a 1/4 inch not enough? I mean, it's only a 64th of an inch, but I don't have the tooling needed to see the amount of movement in there. So even if I were to go above that, I mean, that would be 17/64 would be the next one if I were going to go above. I don't have drill bits for that. So what do we do? I do have a 9/32 drill bit, which would be a couple sizes higher than that. So that could be a viable alternative. But we would need exactly 9 30-seconds rod, and that could be the hard part. So I'm thinking I'm gonna do this. I'm gonna put everything away. Okay, run to the hardware store. If I can get a 9 30-seconds hard steel rod, maybe if it's a 9 30-seconds grade 8 bolt that I just have to modify, I could see that being a good idea. Then, you know, with like a sleeve on it and not have any threads, or if it does have threads, I could just cut those off and, you know, smooth it out on the bottom. I could do that. That could potentially be a solve to our problem. It's the next day, and I have discovered that the hardware store is not the greatest of ideas. I just couldn't find the right size of anything. So we are down to using the stock parts, taking the head off, and filling in the gap with some weld. This is aluminum, so we're gonna have to use a TIG welder. So like I said, this is not gonna be for everyone, but if you have this, I don't know how much a shop would charge you just to fill in a hole, but you could potentially do this yourself if you just have someone else TIG weld it. Or if you're in a Pacific Northwest, let me know if this works out and I'll give you a hand. Having said that, we need to take off the head, which means we need to take off the muffler, the carb, potentially even the cover, and there's 1, 2, 3, 4, 5, 6 head mounting bolts. When you take off the head, you're supposed to get a new head gasket. If it breaks, I'm just going to use some copper silicone because I don't know if this is going to work. If it does work, then we'll get the right head gasket because that's only a couple bucks, but it will take like a week to get here, and I'm a little impatient. I'm going to get this taken off and we'll get going. And after removing the muffler and the carb, we're left with this little part here, which is going to be not what we needed, but like I said, we have to remove these 6 bolts and the head should come right off. Now, I put this as top dead center. How you can tell this is top dead center is on the cam. There's a line, and the line has to be directly facing you. I probably need to adjust it a little bit more, but it's important that you have it adjusted now, because technically the true way of doing this is taking the motor off, taking the pump off, cracking the engine or cracking the crankcase, and they're looking at the timing marks on the crank and then aligning it with the cam and the chain, and there's like this little chain that's a link that's a different color. There's a whole process. As long as you keep it at top dead center for right now, we can proceed. Now, this is the best way, no, but we're going to get it as close as we can. I'm going to adjust it. Looks like from the, well, I can see right here, we're going to have to move this a little bit more over here. So we don't want to be a tooth off, that would be bad, so we're going to get that aligned as much as we can. And then once we are ready to take the cam out, there's this little pin that you just pull out with a pair of pliers, which could be a tad difficult with this in the way, so we might need to remove this little tank for the soap so we can gain access to it. So I'm going to get all that done. Next time you see it, we'll have the head off. And it's off. So head gasket seems like it's doing pretty good. I mean, it's not broken or ripped anywhere, so that's good. And it has a lining on the inside where the piston goes, so that's good. So head is off. I think I'm going to spend a little bit of time and take the valves out. I'm going to clean everything of oil, and then now that we have, what was that? Oh, screws. Didn't take the 10 millimeter out on the bottom. Now that we have full access, I think I'm going to I don't know. I need to find a way to center everything so I know where to drill the hole. So I'm thinking of 2 ideas. One, I start drilling from the top, but then I might egg out the bottom. That's not good. Or the other one is could potentially make like a small little template, or because a lot of the bad area is just on the lower end, I potentially could just weld right there and then go through the top. Yet again, I could still egg out the top, but I don't know. This is why I'm not a machinist. Now, here's a time to set realistic expectations. Do I suspect this is going to work? Probably a little bit. Am I a great welder? No. Is this aluminum welding? Yeah. Is my aluminum welding skills up to par? Probably haven't done it for at least 4 months. So, it's going to be interesting. Is this standard aluminum TIG welding? No, it's not. It's filling in a crater. And then that's about it. So, the only good thing about this is it is pretty thick, so you don't have to worry about that all that much. The problem is it's pretty thick, and aluminum loves nothing more than to be a problem by dispersing heat. Another problem is it's pretty cold outside. I usually would preheat, but the valve guides are still there, and I don't really want to torch them, which is another problem. If it gets too hot, I might torch them anyway. So I have a sink not that far away. So after I'm done welding, I'm going to try to cool this off as fast as I can. So hopefully this works. If not, then the worst case scenario, the motor still doesn't run. For those who are interested, I am running, let's see, it's an AC TIG because it's aluminum. I do not want pulse. I'm going to do 120 amps. The frequency is 100 hertz and the balance is 70 negative, 30 positive. Hopefully we see you on the other side part. Now, here's the other problem with AC TIG welding, or TIG welding, this type of stuff anyway. It's dirty. It's very dirty. Just cast aluminum by itself is inherently dirty. So it's going to be a little bit of a process. I'm going to try to get this done a little bit more, but yeah, just know that I'm going to be here for a moment or two, just kind of trying to fill in that hole. And here is the final result. So, I need to clean this up. The whole piece didn't really get that hot. I kind of nicked right here, but I think it's pretty okay. It's just a nick. But anyway, it's not perfectly round or anything. It's not particularly perfect. And could I take like a grinder, like a Dremel, kind of make this perfect? I could, but it's a little thicker than it was before. I still want to grind down right here, but I think everything should clear just fine. I'm going to take the air compressor, blow all this off, wipe it down real good, and then I'm going to drill the hole first, because there's no point in putting more drills or more scrap pieces of metal just chilling everywhere in there without drilling a hole first. But I think that worked out pretty well. Like I said, cast aluminum, pretty much anything cast is not any welder's preferred medium of anything. Cast is just really dirty. It's really hard, especially when you get to cast iron. It gets a whole different level of difficult. This wasn't all that bad. It did kind of get a little too hot, but the good thing about aluminum and filling a hole is if it starts to get a little misshapen, fill it with more aluminum and shape it yourself. And I think this is probably even better because this is 4043 aluminum, so it should be pretty good. So this is the finished product. I took my Dremel, kind of cleaned up the side so it doesn't look super homemade, and got it looking pretty good, I think. I think it's going to do well. I put the rockers on, and I did put a little extra material on the side apparently, or maybe it shifted, I don't know. So I had to remove a little bit more. But other than that, they both actuate freely. They don't rub, they don't grind. We will give a pull with the cover off so you can see if it actuates right. And if it does, I think we're going to give this thing a test pull to make sure everything is a-okay. Well, it is a moment of truth. Put it all back together. I did have the time, like I said. Man, that was a lot of work, but it's hopefully good. Now, what did it do before? Before, like I said, it was rocking back and forth, and it wasn't allowing the compression release to function. Well, I got it running. However, it needs carb work. Only runs on choke. So, but the fact is, it runs. I've done this at least 2 or 3 times now, and yeah, everything should be good to go. The cam is fine. Everything else looks like it's fine. I'll probably, after I clean the carb, take the cover off just to kind of take a look, make sure everything is good to go. But everything pulls fine. Everything looks to be good so far. So I'm happy that this worked out. Is this a viable repair for most people? No, I mean it's not. But don't get me wrong. If you know someone that has a TIG welder that could do aluminum or even aluminum MIG, all you're doing is filling holes and buying a $2 drill bit. Granted, I did have to use a drill press to make sure it was straight. That part was kind of annoying, but I'm sure if you have a steady enough hand you could do it. I wouldn't recommend it, but I'm sure you could give it a try. Having said that, it's good to go. If you like what you see, keep watching, subscribe, follow me on Instagram at SmallEngine101, and I will catch you on the next video. You have a good rest of your day, and have a good weekend.